All right, this is the video for test number 3, the problems after including question 77. So number 77, this is a very easy question, hopefully. The figure above shows the graph of a function f with domain from 0 to 4, including the endpoints. Which of the statements are true? So the limit as x approaches 2 from the left exists. Does the limit from the right exist? And does the limit overall exist? So from the left, what I'm going to do here is cover up the shades. Okay, I'm only going to look at the left part of the function. So I'm going to start here and go to positive 2. And it looks like from the left, I'm getting closer to a single y value. So this limit exists. Now I'll do it from the right. So I'm going to make the shade go to the right. So as I'm going to the right, I am getting closer and closer to a single y value at 2. I'm approaching a single y value at 2. So the limit from the right exists. But then if I try to squeeze both ways, if I looked at both the left and the right, there's a gap. So the left and the right-hand limits exist, but the function's not continuous, so the limit overall does not exist because the limit as x approaches 2 from the left of f of x does not equal the limit as x approaches 2 from the right of f of x. So I'm going to go with C, 1 and 2 only. Final answer. All right, 84. We have the graph of the derivative function. So this is f prime. And it says it has horizontal tangent lines at -1, 1, and 3. It says which of the following values of x does f have a relative max? So I'm going to draw a little number line here of f prime. F prime helps me determine when the original f has a maximum. So if I have f prime and I am looking to fill in the number line for f prime, I am looking for where this graph is above and below the x-axis. So for example, up to -2, I'm below the x-axis. So up until -2, I'm below the x-axis. Then from 2 on to 1, I'm above. And then from 1 on to 4, I'm also above. So I want to fill in a positive there, making note at 1, I have a 0. And that's not going to matter for this question, but I just want to be technically correct. And then past 4, we're below the x-axis. So from 4 to 5, we're negative. So now we're asking where does f have a relative max? So if f prime is negative, that means f is decreasing. Then if f prime is positive, that means f is increasing. Then if f prime is negative again, that means f is decreasing. So we can only have a maximum where we're going from increasing to decreasing, which is only at 4. 4 only. Choice C is correct. Yes, because they didn't include endpoints. Endpoints are not included in our choices. Otherwise, one could say, well, at -3, perhaps you have a relative maximum, but those weren't included. All right, 86 says the table gives selected values of the velocity of a particle moving along the x-axis. At time t equals 0, the particle is at the origin. It says which of the following could be the graph of position of the particle from 0 to 4? Well, they gave us one really easy piece of information. At t equals 0, the particle is at the origin. These are position graphs, x of t. So when I look at the position, the particle has to start, the x of t has to be at 0. So A is at 0, but B is not. And C is, but D is not. And E is. So right off the bat, just by reading that sentence, you don't have to know a thing about velocity. You just have to be able to read at time t equals 0, the particle is at the origin. Now, at 0, my velocity is -1. So what that means is that the position, so let's draw, this is the particle, is at time equals 0, is at 0. And then, because the velocity is negative, it has to be going backwards at time equals 0 once the clock starts. The particle has to move somewhat backwards. So on the graph, it has to dip below the x-axis. A doesn't do that, so A is out now. So C and E do that. Now, at 1, the velocity is 2. So notice, at 1, what has to happen here is this thing has to turn around, because at t equals 1, and I'm not saying it necessarily goes this far, but the velocity is 2 at t equals 1. So in a neighborhood around t equals 1, this thing's going to be moving to the right, which means its position is going to be increasing. Well, at 1, the position is bottoming out. It's like it's turning around at 1. If I look at choice E, it's not turning around at 1. So now I have a choice between, well, now actually no, I don't have any choices. C is it, because I've eliminated the other 4. All right. Number 88, it says the radius of a sphere is decreasing at a rate of 2 centimeters per second. At the instant when the radius of the sphere is 3 centimeters, what is the rate and change in square centimeters per second of the surface area of the sphere? And I'll be honest, I have to read that one again to myself. The radius of a sphere is decreasing at a rate of 2 centimeters per second. So I write dr dt is -2. At the instant when the radius is 3, what is the rate of change of the surface area of the sphere? So the surface area of the sphere is s equals 4 pi r squared. And I want the rate of change of the surface area. So I would like to take the derivative with respect to time of that equation. And now we'll introduce derivatives. So I have ds dt equals r is a function of t. So I must use the chain rule when I differentiate this. So I want to have the 2 is going to come down. 2 times 4 pi is 8 pi r times the derivative of r with respect to time. So now ds dt is what I'm looking for. They want the rate of change of the surface area. So that's what I want to find. That equals 8 pi times the radius, which is 3, times dr dt, which is -2. And I know I starred this off, which on the sheet, which means you need a calculator, but you don't need a calculator for this. 8 times 3 times -2 is -24 pi. And that is choice B. And one more, and I think we're done. So number 90 says the function f is continuous on the closed interval 2 to 4 and twice differentiable on the open interval 2 to 4. If f prime of 3 is 2 and f double prime of x is less than 0 on the open interval 2 to 4, which of the following could be the table of values for f? I actually think we did this question as a class in our notes. This was a tough one, so follow along here. F prime of 3 equals 2, okay, means that f is increasing at 2. So now if we take a look, all the functions are increasing from 2 onwards. So that's not a very good way to get rid of a choice. But then it says f double prime is less than 0. So f double prime less than 0 means that f is concave down. And if you think about what that means the rate of increase is decreasing. So what's happening is as I go on in time, I'm increasing a lot at the beginning and a little at the end. So I'm gonna look at this and go from 2.5 to 5. Sorry, let me say that again. If I go on a constant x change, so from 2 to 3 I changed 1 unit. If I go to 2.5 to 5, I went up 2.5 units. Then if I go 3 to 4, that's a change in 1 unit. And from 5 to 6.5, that's 1.5 units. That change is slowing down. The rate of change is lessening. So I'm going to keep that choice for now. I want to do the same thing with this guy. This looks like a 2.5 change. That's a 2 change. I want to keep that. This is a 2 change. That's a 1.5 change. I'm going to keep that. This is a change of 2 and then a change of 2. Well, that's showing that the function may not have any concavity. Maybe just be a linear function. So this would not be correct. And then 3.5 to 5 is a change of 1.5. 5 to 7.5 is a change of 2.5. I don't like that either. So now I'm down to A, B, and C. I have to be clever here. What I have to recognize is that the slope at 3 is 2. And this is where it gets a little tricky. This is where this is why I like this question. It really, really makes you understand things. If I at 3, so I want to try to draw this sorry, yes, at 3. At 3, I have a slope of 2. So what's happening here is, if I look at the tangent line always lies above the curve. So if you notice, let's just take A and B for a minute. A and B both place f of 2 at 2.5. Okay? And then f of 3 in both cases, so this is true for choices A and B, f of 3 is 5 in both cases. Now, is that consistent with the tangent line lying above the curve? And my answer, I think, is yes, because if the tangent line has a slope of 2, then I'm going up 2 on the line. I'm going up 2 over 1. So this value should be 3 on the tangent line. So I like the fact that I have 2.5 and 5, 2.5 and 5. I don't like choice C because choice C says the f value is 3, but the f value can't be 3 because the tangent line lies above the curve, and the tangent line's value is 3 at x equals 2. So the graph has to be below the tangent line, so I don't like choice C for that reason. In other words, the derivative having a slope of 2 has to make this change. This has to be greater than 2 because the derivative is 2. So 2.5 and 2.5 work. Using that same logic, when I get past 3 and I go look at the change from 3 to 4, this number has to be less than 2. But 2 is not less than 2. So this choice is out. And let me explain graphically. If I'm on the tangent line graph, okay, the tangent line just goes up 2 over 1. If it went up 2 over 1, this value on the tangent line is 7. But the tangent line has to be above the function. The function has to be below the tangent line. So if the tangent line's at 7, this y value of the green dot that I just made has to be less than 7, 6.5. Another way to look at it is the change between 3 and 4 has to be less than 2 because the derivative at 3 is 2. So A is the only answer that makes sense. B, what's happening is that this change is too large, and that means this 7 would have to match up with the tangent line, and it does, and it should not because the tangent line has to lie above the graph. And that's it.